In this video, we're going to do some practical examples of the product rule. Now, the product rule is stated on your screen there, and in an earlier video, we proved it. Well, now we're going to do a few practical examples. If I want to determine the derivative of this expression, I recognize it as one function times another function. The derivative of that will be f prime of x g of x plus f of x g prime of x. In other words, the derivative of the first function times the second function plus the first function times derivative of the second function. And that's it. Okay, and that's what we get here. So we literally just determined the derivative of the first one, and we multiplied by the second one straight away. And then we added the first one straight away, and we multiplied by the derivative of the second one. Okay. Well, what if I tell you that I want you to determine the value of f prime at -1, given that f of x is equal to this product? Well, you know that f prime of x will be derivative of the first times the second plus the first times derivative of the second. And that's your derivative. Now, that's f prime of x. This particular question is asking us to find f prime of -1, so we're just going to sub in -1 for x and do our evaluations. Okay, so this first step is merely the derivative that we showed in my handwriting a moment ago. And these next steps are simply when you sub in an x value of -1. Ultimately, your final answer is -1,148. So f prime of -1 is -1,148. And you get that just by simply plugging in and evaluating. Okay. In this question here, we want to determine the value of f prime of 1 given that f of x is equal to that expression. Well, we learned in an earlier video something called the power of a function rule. And that's what it's called in your textbook. It can also simply be called the chain rule. We have a polynomial function raised to the exponent 7. So I'm going to determine the derivative outside in. I'm simply going to bring this 7 in front of that polynomial and leave the polynomial alone, the polynomial function, and reduce the exponent by 1. Now, in many of our polynomial questions, the base of the exponent is x. In this particular case, the base of 7 isn't x, it's 4x squared minus 3x plus 1. So when that happens, when we have a more complicated base, we have to do this outside-in process where we bring the 7 in front and leave the 6 as our new exponent. But now we also have to multiply by the derivative of what is inside, what the base of that exponent is. And the derivative there is 8x minus 3. Okay, so that's called power of a function rule. And just to repeat, you bring the 7 in front and you change the exponent to a 6. And then because we had a complicated function as our base of our exponent, we have to multiply by the derivative of that. And so if you're asked for f prime at 1 specifically, that's no problem for us. We simply determine our expression for f prime of x that we had a moment ago in my handwriting, and then we just go about determining f prime at 1 by subbing in an x value of 1, and we get our f prime at 1 value of 2,240. Now, a neat thing about the power rule is that it allows us to say that if we have, this comes up a lot in this course, if we're given an expression like, let's say y is equal to 7 times a function, the derivative of that will simply be 7 times whatever the derivative of that inside part is, which is 6x plus 2. And the reason why we can say that is the product rule. And just to show you what I mean, pretend instead of saying 7 times 3x squared plus 2x plus 6, suppose I said y is equal to f of x times g of x, where f of x is 7 and g of x is 3x squared plus 2x plus 6. If we thought of it that way, we could do the product rule. And we could say y prime is the derivative of the first. So if f of x is 7, then f prime of x will be 0, times the second, so simply put 3x squared plus 2x plus 6 down, plus the first, which is 7, that first function is 7, times the derivative of the second, which is 6x plus 2. Now, this 0 times 3x squared plus 2x plus 6 obviously falls away, and we just get 7 times 6x plus 2. So a lot of times in this course, you'll be asked to determine the derivative of something like 7 times 3x squared plus 2x plus 6, and you'll get used to simply doing 7 times the derivative of the function itself, 6x plus 2. Okay? And again, this is us just showing it a little more neatly. And that's the end of our product rule video.